73. If he is giving value 54 for this looking attributes, we will write. And then for durability, if he is giving 85, so we will put all the values and we will get the discriminant discriminant score, discriminant score of this particular individual. Okay, so discriminant, so we will see the discriminant score in the table. So I am showing you the table. I am stop sharing this and opening the main table. So here you can see this. So I saved two values. One is this, these are the discriminant score. The discriminant positive discriminant score is showing you the buyers, they means potential buyer will buy the product. So I saved two values, one is group and another for score. So means purchase, the value means positive value here, positive value indicating that these are the discriminant score. Okay, so positive value means they will buy the product, and the negative value showing they will not buy the product. So here two cases, 16 number and 70 number, their values negative value, it means they will not buy the product. And same as here, the negative values showing they will not buy the product, and positive value they will buy the product. So here the positive value it is showing, it's a misclassification case. Actually it should be negative, but it is coming positive. Okay, so he will not buy, it is a misclassification. And again another the 0.140, it is again misclassification. So out of the 42 misclassification case we can see here in the purchase group, and two misclassification case in not purchase, would not purchase group. So my model is correctly classifying the 90%. Now your question is what is filter? Filter means this filter when we when we select the file. Okay, when we select the file in a in one group, so it will give the filter, means my cases has been filtered. It means out of the 80 I can use only 40 cases I have filtered, means I am using only here 40 cases out of the 40, out of the 80 cases. So filtered means to select the cases. Now I can use, so this is, now I can use it for cross validation purpose also within a 1 minute. So I am just select file, all cases, and then cut. Now I am using the estimation and cross validation both. Okay, so I am deleting these variables like filter and these only three, there is no need. And then I am dividing the split. Okay, now I want to simultaneously analyze the estimation and validation both. Okay, then how to perform it? Analyze, classify and discriminant. First of all I will split the file. So data split file, it is already split it, so there is no need to do anything. So analyze, classify, and then discriminant. Okay, so by default all the values here, and then okay, now I can show you the output. So the output is, now you can see the output. Okay, this is the output. So you can get the output, means this is the original 40, you can see here estimation sample. Okay, 40 estimation sample, 40 validation sample. So in this another model, the estimation sample 40 cases and validation sample 40 cases. So result are more or less same. There is no, the estimation sample and validation sample is giving the right result. So there is no issue of cross validation. Okay. And another result we can see, the all the results are more or less same. So there is no issue of cross validation. So now I am going to start the new topic. How to create filter, I told you. Okay. So now next is mm, moderation. Moderation. Moderation in regression. I think you can see this word file, moderation in regression. So there are two terms. One is moderation and another is mediation. So we should understand the difference between the moderation and mediation. So moderator variables, there are some variables like moderator variables influence the strength or direction of relationship between an independent and dependent variables. Okay. Now the what does it mean? The moderation basically, it is a you can see the graph, the picture of this. So there are, I'm just showing you the view. uh, yes. Okay. Now I think you can see. So in a moderation, what is moderation? Moderation basically, it is a independent variables. And mm, I'm explaining to, yes. Okay. So moderator variables influence the strength or direction of relationship between independent variable and dependent variable. So here you can see one independent variable and one independent. So this is y, that is dv. dv means dependent variable and iv means independent variable x, and this is moderator. So the moderator variable, what does moderator variable do? See, moderator variable influence the strength or direction between the relationship between one independent variable and another dependent variable. It means if we are not taking this variable, I am just simply taking the two variable, one dependent variable and another independent variable. So if the relationship between the two variables are significant, it means there is a significant relationship between the independent and independent variable, then without adding the moderator variable, the relationship significant. But moderator variable influence the strength or direction of between the independent and dependent variable. So what does it mean? If its strength means b, it is 0.8, so it can reduce the direction, means it can change the relationship between the x and y, or this variable can change the direction and strength means it can make it more stronger or more less or weak. It can weak the strength between the two variables. It means if before moderator variable the strength is 0.5, then with the presence of the, it may decrease 0.23. And second, if the relationship between the positive with the presence of the moderation, it can uh, change the direction of the two variables, means it may negative. Okay, so there are three things in the moderation moderator. So the dependent variable, independent variable, and moderator variable. Now condition, there may be three types of conditions. One condition, the data means dependent variable. This is continuous, it should be continuous always. Okay, this is continuous. And there may be three condition. One, this data is categorical means nominal. Okay, or nominal. And again it is categorical data. So first condition is the y that is continuous or metric, and x and plus moderator both are non-metric means categorical. Non-metric means categorical. Category may be two or three. Okay, so if there may be three types of predictor variable. One, when both the independent and moderator variable are categorical. Okay, one condition. Second condition may be the one second condition, this dependent variable continuous. I told you it will uh, continuous, always we will take it continuous variable. And second is, this is a categorical moderator. Okay, and this is continuous. Second condition is this. Okay, and third, what would be the third condition? In the third condition, uh, all the three variables in continuous, means third condition means this dependent variable continuous, this is also continuous, this is also continuous. It means all the three variables should be continuous form. So there are three types of situations. So one is no, dv cannot be categorical, because it will not fit. Dv will not categorical. Okay, because in a multiple regression analysis you should keep in mind always, in a multiple regression analysis, because we are using moderator in regression, so all the variables should be categorical, oh sorry, continuous, all variable, either dependent and independent variables. Okay, but some special cases, the first condition is all the variables should be metric, and second condition would be x1 plus this is metric, and this one non-metric, and this is metric, and third condition both are metric. Okay, now I am explaining one by one. The first condition, uh, so the first condition, that is the types of predictor variables. So there are three conditions. One is the types of predictor variable. One, interaction between. So this moderation is known as interaction. Okay. So theoretically or statistically, how to draw this? The statistically, the diagram of this variable, the y. This is the um, moderation diagram. Here you can see the y and this variable x. Okay, and this is the regression coefficient b1, another variable y, and this is the regression coefficient this, and x into m, this is the interaction. Okay, that is, this is B3. So statistically, we will check the impact of this interaction term on y, independent variable. So generally we take the two cases in a categorical. Means this should be metric and metric. One case is non-metric. Okay, first the first case this. Okay, second we take metric, and third is metric. But if both the metric means, it's not a perfectly case of the moderation. Means if we take the uh, this is non-metric and metric, so it's a case of simple factorial ANOVA. Means, so instead of using the regression analysis, we use here factorial ANOVA in the first case. Okay, so here there are three types of interaction between two categorical. If we are using two categorical variable, then we will use factorial ANOVA. Otherwise, if we want to use the if we want to use multiple regression analysis, okay, by using both the categorical variable, then we will convert these categorical variable into dummy coded dummy variables. Okay, second case, the interaction of between one quantitative and another uh, categorical. ठीक है, सेकेंड कंडीशन क्या हो सकती है, जैसे मैंने अभी बताया, वन क्वांटिटेटिव, दिस वन मीन्स दिस इज metric and this is metric and this one is non-metric. Okay, now here we will use multiple regression analysis. It is the perfect condition. And second, third may be metric, when this is metric, and this one is metric. Okay, so I am taking three case studies. One for two categorical data, means this one is non-metric and this one is non-metric. Okay, and this is metric. Second condition, this is metric, this is non-metric. And third condition, this is metric, this one metric, and this one, all the three variables metric form. So one by one I will take the I will explain through the example. Like at least one of variable should be continuous in these three conditions. Sir, is it like at least? Yes, one condition, the continuous variable, always the dependent variable should be continuous. Okay, now I'm taking the simple case study to explain the this. Okay, so I'm stopping share this slide and taking this simple case study. Stop sharing and case of categorical moderator this. Okay, this is the case. So it is no, it is a continuous. So stop sharing. I am using categorical continuous categorical moderator. Yes. Okay, can you see this slide? Is it visible? Okay, you can see this slide. Okay, so there are three variables you can see here. Y, that is this y dependent variable, x independent variable, and m uh, the moderator variable. Okay, so there are in this case study you can see the salary one independent variable male and female means gender, and third is there are three types of college. One is arts college, science college, and commerce college. Okay, so here we can see the this data set. So in this case study we want to know whether gender, is it any significant difference between getting salary by male and female, or is it any significant difference between getting salary by commerce college teachers, science teachers, and arts science, commerce, and art teachers. So it's a case of the two here we are taking two, all the variables means two categorical variable. Your the it's a first case, this is my dependent variable, this one is x independent variable, and this is uh, this moderator variable. Okay, so we want to check whether interaction is working or not. Okay, now here this is categorical means non-metric data, non-metric data, and this is metric data. The non-metric means two categories, male and female. Non-metric means arts, commerce, and science, three categories. So we will use here factorial ANOVA instead of multiple regression analysis, because if we use it, then we will use dummy coded dummy variables. Okay, we will convert these variable into the dummy variables, and it's a long process. And then interaction, if the advantage of factorial ANOVA is it will give the interaction effect by default. Okay, so I am just uh, using the factorial ANOVA. So analyze, sorry, analyze, and then so but before analyzing the factorial ANOVA, I want to check whether the relationship between independent and dependent variable significant or not. Okay, whether the is it any discrimination of salary for male and female teachers. Okay, so I want to check through independent sample t-test. So analyze, compare means, and independent sample t-test, salary dependent variable, gender independent variable. So there are two group, one 0 and 1, and then continue, and then okay. So my output is, I am showing you the output. So this is output, and through output we can see we will interpret here this table. So the mean salary of female 40.8, mean salary of male 49.9. It means there is a difference, but whether this difference significant or not, so we will check through the p value, and here p value less than 0.05, it means there is a significant difference between the salary getting by female and male teachers in the particular sector. Okay, so this would be the, so here this is the significant. Now we want to check, is it any significant difference for science teachers, commerce teachers, or arts teacher. So here again I am using, but here there are three category. So I will use here independent. I'm comparing three categories. So one way ANOVA. So analyze, compare means, and one way ANOVA, and salary dependent variable and college independent variables, and nothing to do here. Bonferroni, continue, options, descriptive, this, and then continue, and after continue, okay. So what would be the result, whether is it significant or not? So I am showing you. So here the output, you can see there is the ANOVA table. So this table tell us whether the significant difference between getting salary by the three types of teacher: science, commerce, and arts. So there is no significant, because p value less than zero point 0, greater than 0.05. Now I'm using the factorial ANOVA for checking the interaction effect of independent and moderator. Okay, so here we will use factorial ANOVA, analyze, then general linear model, and then univariate. Okay, univariate, and then salary we will put here in a dependent, because it is dependent variable, and the both the variable gender and college we will transfer in the factors list. Okay, and then the model, here nothing to do, just uh, plots only. Okay, okay. So okay, then we will get the output. So I am showing you the output. So output of this is okay. Now this is the output. Now we want to check the output. So through this output, so gender, so there are two category of gender: male, 20 male, and sorry, 20 female, and 30 male. Okay, and college, there are three types of college: arts college, science college, and commerce college. So 22 teachers in art college, 17 in science college, and 11 teachers in the commerce. So in the independent test, we checked whether the salary of male and female is significant or not. So through independent t-test, we found there is a significant difference between salary getting by male and female teachers. Okay, so here we can check. So this the independent variable x. Now what is the p value? It is significant. Okay, now when we used in one way ANOVA for comparing several group, means arts teachers, science teachers, and commerce teachers, we found there was no significant difference. Or so ANOVA table, this was my ANOVA table, and we found there was no significant difference because p value was greater than 0.05. And here we can see the p value m, that is moderator, and what is the p value here? 0.16. There is no significant difference between the two variable. Okay, and third, the interaction, basically it's a multiplication or moderation effect, whether the when we combine both, whether it is significantly contributing to dependent variable or not. So here the p value, it is greater than 0.05. So we can see here there is no significant impact of interaction term. So when we use moderation, there would be two possibility: either moderation effect will be significant or not significant. Okay, now the I'm stop sharing this, and my another case study for the in the variable, this is okay. Now the second case study I'm taking the categorical variable, one this categorical gender and male and female, male, and the simple regression equation for male and simple regression equation for female. And this is the uh, this the categorical moderation. Here we can see this is the categorical moderation. So I will explain this categorical moderator through Potter's theory of job satisfaction. So what is the theory of Potter's job satisfaction? Theory in this variable, in this diagram, we can see there are three terms: employee turnover, job satisfaction, and job performance. Okay. So first of all, we should define the variables. So there are three types of variable. Employee turnover. High employee turnover means maximum people leave the job during the particular year. So it is continuous variable. I told you dv always will be continuous, or metric, it is continuous. Now job satisfaction, it is iv, it is continuous. And third moderator variable, that is uh, job performance, categorical. Categorical means there are two category: low job performer, low job performer, and uh, job high job performer. So there are two types of people in an organization. So job performance, high and low. So this is categorical variable. This is continuous. Job satisfaction means 0 to 100. And employee turnover again. So it is continuous variable. Ratio scale, it is ratio scale question, it is ratio scale, and it is categorical. So there are two main moderator we will use here, one categorical and another next type, that is continuous. So basically we use two types of moderator, one is categorical and another is continuous. Okay. So in this case study, I will explain this case study in next session. So we will break. Okay. So and after that we will take we will solve this case study through regression and as well as process macro. This is another software, so you can download easily. It is free software, process macro. So oh sorry, not 11:30, 9:32. Okay, okay, I'm sorry, I'm confused. So I will not take break. Actually, I thought 11:30. So the break will be 11:30. So no problem, sir. Okay. So this is the case study of the categorical moderator. So in the categorical moderator, the Potter's theory of job satisfaction. So this theory says that employee, if people are less satisfied in the organization, they leave the job. Okay. So means there is a negative relationship between employee turnover and job satisfaction. High job satisfaction, low employee turnover. Low job satisfaction, high employee turnover. So the relationship between the two, it is inverse relationship. Okay. Now through the categorical moderator, so what will we do? We will divide our group into two, one for low job performers and another for high job performers. Okay. Now we want to check whether job satisfaction are high with low performer or not. Because if low job performer, whether low job performer satisfied or not. And another condition, high job performers, whether high job performer satisfied in the organization or not. So there may be difference. There may be possibility that low job performers are not satisfied in the organization, and For high job performers, there may be possibility that high job performers are satisfied in the organization. So through interaction effect, we want to check whether these people are satisfied or not. Okay. So we use the first, we will check the relationship between the employee turnover and job satisfaction. Means we will check the simple relationship between employee turnover and job satisfaction, and here we are not including the job performance. We want to know the nature of our data. Okay, so through employee turnover and job satisfaction, we will check whether it is significant difference or not. Second, employee turnover and job performance, we will find the uh, relationship between employee turnover and job performer. So there are two types of job performer: low job performer and high job performer. So the dependent variable continuous, independent variable categorical. So we will use here independent t test whether the job performance uh, the influence the employee turnover or not. Okay. And third condition, we can use NCOVA, means simultaneously we will take the job satisfaction and job performance both. Okay. So now we start the case study one. So in a categorical moderator, we will use two case study. One where there is a uh, moderation effect, and another case study where there is a no moderation effect. Same as in a type third, we will use two case study. One, we want to check the full moderation, means moderation effect, and another case study we will take no moderation effect. So we should understand the two. Okay. Now the I am taking the case study. So first of all, I will use SPSS. I will analyze these techniques through SPSS, and after that I will use process macro software. Okay. So my case study categorical moderator 2. Now this is my case study. I'm using this case study categorical moderator 2. This is case study. So in this case study, so there are three variables. First of all, we see our data. There are three variables. One is salary, experience, and gender. So there are three variables. So here two continuous variable, means dependent variable continuous, independent variable continuous, and moderator variable categorical variable. Okay. So this is there are three variables we are using here. Y means dependent variable salary, X means independent variable experience in years, and M means gender categorical variables. So it's a data set of 50 people data. Okay. So this is a very simple case study. Here we will check the impact of male and female. So in this case study, there is no interaction effect. Okay. So first of all, here I will check whether moderation effect significant or not. Okay. So this is the it is another case study. So second case study, I will use high job performer and low job performer. Okay. So in this case study, we want to know the salary depend on number of experience or not. Salary depend on male or female. Okay. So first of all, we will use simple regression analysis, analyze, then regression linear. Okay. So salary dependent variable, experience independent variable. We can use simple regression equation because both the variables continuous, and we want to check whether number of years means experience influence the salary or not. What is the relationship between the two variables? Is it positive or negative? Okay. So okay, I am doing okay means I transferred salary independent and experience in independent variables, and okay. So this is my result. What is the result output? This okay. This is my table. So through this table, we can see here the last table coefficient. So experience, it is independent variable and salary dependent variable, and we can see it is significantly contributing to the dependent variable. It means the relationship between the two are significant. Okay. So here the relationship between the two, we can see here, देखिए, what is the relationship? The p value, this is my equation, y equal to 35.434 plus 1.547 into experience in years. So the relationship, it is significant because p value 0.05 and positive relationship, the value of regression coefficient, that is positive. So there is a positive correlation. So in this case, we found there is a positive correlation between the experience and salary getting by employee. Now second case, we will use here the independent t-test. Okay. So through means we will compare the two group, one male and another female, with the salary. So here we are using independent t-test. Compare means independent sample t-test. Salary as a dependent variable and gender, it is independent variable. So there are two defined groups. So I coded 0 for female and 1 for male. So I will write here 0 and 1 for male, and then continue, and after continue, okay, and then we will see the result. So I am stop sharing it and sharing the output. So output is this. You can see the output. So in this output, the t value is this. T value minus t value minus 0.3. You can see the t value minus 0.360 and p value 0.001, means less than 0.05. So through second condition, we found there is a significant difference between salary getting by male and female teachers. Okay, male and female teachers in a private sector, because the salary of mean salary of female 40.8 and mean salary of male 49.9. So there is a difference. Whether this difference significant or not, so through this p value decides, p value tell us whether this difference is significant or not. So we should keep in mind, or when we compare two or three groups, always we will get the mean difference in either two group or three group. But whether this difference is significant or not, so p value decide. P value tell us if p value is less than 0.05, it means there is a significant difference. So no, so in the first step through simple regression, we found significant difference between salary and experience. Okay, and through independent t-test, we found there is a significant difference between getting salary male and female. So in both the conditions we found there is a significant impact. Now we use multiple regression analysis. We want to check the interaction effect. Now we will convert our data. So in the third stage, I'm stop sharing this and opening my file. So this is my file. Now interaction effect. So we will create new variable. How to create new variable? We go to transform, compute variable, transform, compute variables, and यहाँ पर लिखेंगे हम इंट्रैक्शन Okay, so compute variable interaction, because we are creating the new variable. The name of new variable is interaction, and then interaction between gender and experience. So I am transferring here gender and multiply by experience. Okay, so M and X, this M and X, this is the interaction multiplication, M multiply by this, and then continue. And after continue, so where is my file? Categorical moderator 2. This is, now you can see the data. Okay, so this is, now you can see the interaction term. So when we use moderation through multiple regression analysis, we use interaction term. I told you earlier, the theory of moderation is, there are, this is the theory, means one moderator and another independent variable, this is dependent variable, and then this is moderator. So statistically how to write it? Y, and this is X independent variable, B1, M categorical variable, moderator variable categorical, and this moderator variable also, it is a type of independent variable. Okay, so this is B2, and then interaction of X and multiplication of this, and then it's a B3. So we will use multiple regression analysis like y equal to b0 plus b1 x1 plus b2 x not x2, it is b2 m, and plus b3 x multiplication m. So here we will check interaction effect through multiple regression analysis. Earlier we used two equation. One is simple bivariate regression analysis, means y equal to b0 plus b1 x1, and we checked whether this experience, number of experience, influence the dependent variable or not. So we found p value was 0.05, less than 0.05. It means number of experience significantly contributing to the salary. As your experience increases, your salary will increase. And second, we found the uh, difference between the male and female salary. Okay, so again we found there is a significant difference between the salary getting by male and female. And now third is, now we are taking all the three variables. One is this independent variable, this moderator, and this interaction, and we want to check the impact of this. If its value p less than 0.05, then we can say there is a significant impact of interaction effect. If its value greater than 0.05, when we will say there is no interaction effect. Okay, now we will use multiple regression analysis. Yes, your question, Atul Kumar. Is it possible where DV and moderator are continuous and IDV independent variable is categorical? Yes, it is possible. Now, so I am performing multiple regression analysis. I am taking all the three variable, independent variable X, M, and interaction. Okay. Now, how to perform it? Analyze, and then regression and linear. Okay, I am performing multiple regression analysis. Now analyze regression and regression linear, and then the salary, it is dependent variable y, experience, it is independent variable, gender, it is independent variable, interaction, it is independent variable, and then statistics, nothing to do. I need only descriptive statistics, and then continue and okay, because I want to see only the interaction effect, whether it is significant or not. So okay, and after okay, my output has come. I'm stop sharing this slide and sharing output. Atulji, dependent variable cannot be, yeah, this is not, cannot be categorical. Your question, can DV be categorical? No, it cannot be categorical. Okay, now this is, so I'm sharing the output. This is my output. Okay. Now through output, we will check whether significant difference, yes or no. Okay. So here, through this ANOVA table, so I am interpreting this table again. So in a model summary, So multiple R 0.88 to R square 0.778, it means 77.8% varies through the variables. And model is significant because p value, it is where is model is significant because p value less than 0.05 univariate. This is my model. So I am repeating again, actually it misplaced. So the output, the categorical moderation, analyze, regression. Okay. Now this is my output. I am again showing the output. So this output you can see here. So in this output, the uh, ANOVA table tell us whether the significant difference or not, whatever independent we are taking in our study. So here we are taking three independent variables. One is experience, gender, and interaction. So there is a significant impact. But through coefficient table, we will find which particular independent variable is significantly contributing or not. Here, experience, this is the, in the model one, we can see here experience. So what is the value experience? There is a significant relationship between the two. So the experience, experience means as the people, uh, means as experience increases, means as the experience increase, the salary also increase. Now we can see here the through the graph. So the this is number of experience years, है ना, experience, and y is salary. So we can see there is a positive correlation, and this is significant because p value less than 0.05. Now the gender, it is categorical variable. So there is no impact of gender when we are taking the two simultaneously, means independent variable and gender. But when we checked separately, then we found there is a significant difference in gender and as well as number of experience. So moderator effect, this moderator effect, you can see this is moderator and this is independent variable. Okay, in this diagram, when we take separately relationship between x and y, it was significant. When we take separately, it is significant. But when we include the interaction term of x and m, then we found this relationship not significant. It is not significant. And a impact of interaction, whether it is significant or not. So here we see the point for 28. So 0.423, which is greater than 0.05. It is not significant. This interaction, this moderation means gender, as a gender moderator variable is not working here. Okay, so there may be two situations. One, there may be impact of moderator, and another is there is no impact of moderator. So it's a case of there is no impact of moderator. In the next case study, I will take impact, means the significant impact of the moderator variable or interaction term. Okay, so through this the clear this, and we can check the interaction through the graph also. So I am preparing, I am drawing the graph. I am stop sharing this, and I am graph. This is my data. Okay, This is the graph. Okay. This we want to check the interaction effect of graph. So graph and chart builder, okay, and then the graph scatter diagram, the salary. This I think you cannot see it due to some uh, pro- and then experience. So I will show you the graph, and then gender and clause, and then okay. Now I am sharing the output. Output is this output. Now you can see the output. So double clicking it, so I am drawing the regression line. I use elements, and you can see fit line at subgroup. So fit line at subgroup, and then clause, and then okay. So here there is no interaction term. Okay. So because lines are uh, not exactly parallel, but lines are not cutting, interacting to each other. So here we can see there is no interaction term. Interaction term means key, for example, this is my graph, and the one line is this, and another line is this. This is the interaction. Okay, intersect two lines. This is interaction effect. But here there is no interaction effect because these two lines are not cutting to each other in this particular region. So through graph we can check whether interaction is present or not. So we should produce graph also when we use moderation to okay. Now second case study, I am using the same case study which I told you, the low job performer and high job performers. So it is based on the Potter's theory of job satisfaction. Okay, so in this case study, uh, there are two group: low job performers and high job performers. So this case study, where is, I am using the moderation. This okay, categorical moderator. Yeah, categorical moderation. So Porter's theory of job satisfaction. So I will cover it in next section. So
Yes, sir. Can we take a short break, sir?
yes,
Here.
yes, yes, madam, yes, yes.
So yes, participants, here we take a short break of 30 minutes, and you are all are requested to join at sharp 12 o'clock. Otherwise, you gonna miss, sir's lecture. And also, here's an announcement for you all that we are starting the sessions sharp at 9:30 in the morning. So you all are supposed to join by 9:15. Fine. So, and also we'll be taking the attendance at 9:30. Today also we took the attendance at 9:30. So please do not risk yourself in any of the cases. Please join on time. Thank you so much. And we'll be meeting at 12 o'clock now.
ओके अंचल मैम, ठीक है फिर, बस है ना,
हाँ हाँ
आज
ठीक है,
मेल भी कर देंगे आज।
ईमेल भी आ जाएगा, ठीक है। Sir, start करें?
हाँ मैडम, बिल्कुल बिल्कुल।
Okay,
ठीक
sir. So
ठीक है, ठीक
platform is all yours, sir.
ठीक ठीक, थैंक यू मैडम।
Okay, sir.
Welcome back, dear participants. So now I am taking the case study theory. This case study about the job satisfaction and job performance. Let's say water theory of job satisfaction. So there are three variables in the moderation. One dependent variable, employee turnover, depend on the job satisfaction, and moderator variable, job performance. It is categorical variable. So in this case study, this theory says employee turnover depend on satisfaction. So there is a significant relationship. But this job performance moderator variable influence the relationship between the job satisfaction and employee turnover. The purpose of moderator variable to change the relationship between the variables, or it means it reduce the strength of the relationship between the two variables, or improve the strength of the two variables, and it may change the sign between the relationship between the two variables. Sign means if it is positive relationship between the two variables, then it can change the sign between the two variables. Okay, now this theory means ki job satisfaction, the people uh, who have high job satisfaction, the employee turnover less, and the people who are not satisfied, then employee turnover high, and job for high job satisfaction, employee turnover low. It means reciprocal relationship between the job satisfaction and employee turnover. Employee turnover high means less job satisfaction. Employee turnover low means high job satisfaction. Now in this case study, so there are two things. One is low job performance and another is high job performance. So the employee turnover, we will find the relationship. One is for low job performer. We want to check whether the relationship between the two variable, employee turnover and job satisfaction, is it significant or not for low job performer. And then we can check the relationship between employee turnover and job satisfaction for high job performers. Okay, so this is case study, and we use simple regression analysis, independent analysis, and ANCOVA to understand the nature. And finally we use moderation term, means interaction term. We include interaction term in our study. Now this so I am using the case study, the categorical moderator 3. Moderation categorical, I am selecting the case study, the categorical moderator 3. This is the case study. You can see the case study. In this case study, there are three variables: y dependent variable, x independent variable, and m moderator variable. Uh, it's very short case study. Only 12 observations you can see. So 6 observation of low job performance and 6 observations of high job performance. So now we can see our data in a date variable view. Y, that is meaning of Y is employee turnover. X, independent variable, means job satisfaction. Moderator variable, job performance. And there are two categories. So it's a 0 means low performer and 1 means high performer. And it is nominal data. So here you can see nominal, and both the variables scale. Okay. This now we simply use regression analysis. Means we want to check the relationship between Y and X. Okay. What is the relationship between X and Y? Both are dependent, both independent and dependent variable are metric form. So we will apply simple regression analysis. So how to do it? Analyze and then regression and linear. Okay. Then linear, and after this the dependent, what is dependent variable? Employee turnover. And independent variable, job satisfaction. Okay. And then statistics, descriptive, continue, and then okay. After okay, you will see the output. I am showing you the output. This is output. So what is the output? The output is the dependent, here dependent variable employee turnover and independent variable job satisfaction. What is the relationship? It is not significant. Not significant means p value greater than 0.05. So in this output, we can say that there is a no relationship between the, although it is a negative relationship, because beta constant you can see it's a negative, but it is not significant relationship. So here y equal to what is y? Y is employee turnover equal to 74.419 minus 0.648 into x. And what is x? Job satisfaction. Job satisfaction. It means there is a negative relationship between x, job satisfaction, and y. It means the job satisfaction, this is job satisfaction in x-axis, and y employee turnover. It means job satisfaction increase, employee turnover decrease. Means less job satisfaction, high employee turnover. When job satisfaction increase, employee turnover reduce. Okay, job. So there is a negative relationship between the two variables. Okay, but this relationship is not significant because p value greater than 0.05. It is not, because p value, it is 0.142. It is greater than 5%, means 14.2%. So it is not significant. Not significant. Okay. Now another relationship we find between the uh, analysis of the independent t-test. So I am stop sharing this and opening my data. So my categorical moderation here this. Now we will check whether the is it any significant relationship between employee turnover and low job performer and high job performer. Okay, so how will we check it? Because here the independent variable it is categorical. So when independent variable is categorical and dependent variable is uh, continuous, there are two variable y and x. So here earlier we checked the relationship between y and x and both were metric form. Okay, because it was the job employee turnover and job satisfaction, both are in continuous, these two variables y and x. Now second condition, we are comparing job employee turnover with this moderator variable. So this is uh, categorical low and high job performance, and this y that is dependent variable employee turnover. Okay, now we want to check whether the job satisfaction the employee turnover same for low performer or high performer. Okay, so because we want to check whether is it significant difference or not. So our null hypothesis says there is no significant difference between employee turnover for low performer and high performer. But alternate hypothesis says there is a significant impact. So how to check it? So we will check it through the independent t-test. Okay. So I am applying independent t-test. Analyze, compare means when we compare two groups, we use independent t-test. For more than two groups, we use one-way ANOVA. So analyze, compare groups, compare means independent sample t-test, and you can see here this is our variable. So variable employee turnover dependent variable, I am transferring it into the test variable box, and job performance, so it is 0 and 1 the coding of this. So job performance I am transferring in grouping variable because categorical variable we take here, and then define groups. So there are two groups 0 and 1. 0 means low performer and 1 means high performer. 0 and 1 and then continue. Okay. And then okay. After okay, we will see the result. So I am showing you the slide. Stop sharing and output. The output of this. Now we can see here. This is the output. So this output says there is a no significant difference between the low performer and high performer of the employee turnover for employee turnover, because p value here, p value we can see the p value it is greater than 0.05, because this is a difference. Mean means employee turnover low job performer employee turnover mean value high, and high job performers mean employee turnover value low. But whether this difference significant or not, this p value decide, and p value it is greater than 0.075 point, it is greater than 0.05, and its value is 0.147. It means there is no significant difference between low performer and high performer with respect to the employee turnover. ठीक है, तो in both the cases we found the insignificant relationship. Okay, in both earlier the relationship between employee turnover and job satisfaction was not significant. Here employee turnover and job performance, not significant relationship. Now third case. Now we will use interaction term. Okay, interaction term. So I am stop sharing this and opening my file. Now third is we will create the new term. Okay, so we can check the relationship between the two interaction term, means this multiply this. So we will create the new variable here, the fourth variable. So how to create the new variable? So a transform, we go to transform and compute variables. If we want to create new variable, so we go for transform, compute variable, and then compute transform, compute variable, okay, and then target variable. So I want to write the name interaction, interaction, okay. So I am copying it, copy and paste in labels, and then continue, and after continuing, so job performance multiply by satisfaction, okay, satisfaction, this is x satisfaction, and then okay, this okay. So after okay, what is, sir, can we calculate interaction effect only of categorical variables, or we can conduct it for both? So we can check interaction effect for categorical and continuous, both scale, okay. Now the I am showing you this interaction term. So I am stop sharing this and I am showing you this interaction new variable, okay. So this is my new variable interaction. It's just a multiplication of two variable, 28 into 0 0. So you can check 44 into 1 44, 20 into 1. So this is interaction term. Now I am using multiple regression analysis to find the impact of interaction term, okay. So analyze and then regression linear, analyze regression linear, and then here reset. So employee turnover, it is dependent variable, job satisfaction independent variable, job performance independent variable, and interaction independent variable, okay. And then statistics, I'm clicking statistics, the descriptive statistics, and then continue and okay. Now we check the output, we see the output. Now this is my output. So through this output we can see here So there are three in this coefficient table. We can see here there is significant. It means job satisfaction. It is significantly contributing. The job performance, it is significantly contributing. Interaction, it is significantly contributing. Okay, it means for job satisfaction, job job satisfaction, what is the p value? It is p value less than 0.05. It means significant. The second, job performance, job performance, job performance, job performance p value, it is less than 0.05. It is significant. And third, interaction term, interaction p value less than 0.05. Again, it is significant. Okay. So earlier we found that when separately we are taking all the three variables, this is y, x, and m. When we are taking separately this employee turnover and job satisfaction, and this is employee performance. So when we separately check the relationship between employee turnover and job satisfaction, it was not significant because p value was greater than 0.05. And when separately we check the relationship between employee turnover and the employee performance, the p value was 0.05. Okay, but when we take multiplication of this x and m, interaction effect, then we found there is a significant impact here in job satisfaction, job performance, and interaction. It means, so the moderator, this particular moderator variable working here. Okay, due to this, the relationship between, earlier it was not significant, but with the presence of this moderator variable, it changed the relationship between the dependent and independent variable. Okay, now you can see the impact. Earlier it was not significant, but including the moderation and this independent variable, the relationship between the job performance and employee turnover significant. And interaction term, it means interaction is working, means moderator variable, it is working because it is uh, p value less than less than 0.05. In earlier case, our interaction term was not significantly contributing because the relationship did not change. But here we are looking the before when we separately check the relationship between the two variable, it is not significant, but in the presence of the moderator variable, it changed the relationship between. So it means here the moderator variable is working. Okay, and so we can check it through this. Now question is, the moderator variable is working, but we do not know whether this moderator variable effective or significant for low job performer or high job performer. We know that the interaction term is working, but we do not know whether it is significant for low job performer or high job performer, because here this output says the job satisfaction is statistically significant with the employee turnover, but we do not know still whether it is significant for low job performer or high job performer, because moderator is saying that there is a significant difference. Now how to check it, whether it is significant for low job performer or high job performer? So we will use we will split our file and then check the difference. So I am uh, stop this and sharing my slide. This is categorical moderator. So your question is, how can we decide that variable is independent or moderator variable? Okay. So actually theory decides. When you are using moderation and mediation in your study, you should go through the literature review. Through literature review, we will uh, get idea about the dependent and independent and moderator variables. So through literature review, and we should not take any variable in our choice that this would be the moderator or mediator variable. Theory suggests us. So we go through the literature review and theory. If theory says this would be the dependent variable, this one independent variable, this one moderator variable, then we can apply. Without theory, we should not use mediation and moderation technique. Okay. Mm. Now I think you can see this table along. Now I want to check the relation, the interaction term. Now we know that interaction term is working, but we do not know for low performer it is working or high performer. So we will split the file. How to split the file? So data, we go for data. So and then split. You can see the split. I am splitting the file. I want to compare the relationship between job performers and employee turnover. Okay, data, split file, and then compare group. Okay, I want to split file for job performers. Job performers. There are two groups: one low job performer and high job performer. And then okay, my file has been splitted. So categorical variable 3. Okay, how do we know that whether our file is splitted or not? So you can see lower right corner, you can see here it is written split by M. M means this moderator variable. Now I am applying again simple regression analysis. So analyze, regression, and then linear. Okay. Analyze, regression, linear, and then okay. Reset it. Employee turnover dependent variable, job satisfaction independent variable, and uh, I want the relationship between the two, and then okay. And after okay, now I'm showing you the output. This is output. Okay. Uh, so the output is, so the first output, descriptive statistics. In this descriptive statistics, we can see here descriptive statistics. What does it says? Descriptive statistics tell about the score of low performer and high performers. So the mean score of low performer employee turnover, that is 58.33, and for high performer it is 41.61. There is difference. It means low performers are highly dissatisfied. That is why they leave the job, because their employee turnover high. And high job performer, they are more satisfied. Their employee turnover is less. Okay, I am comparing employee turnover of low performer and employee turnover of high performer. Here we can see the low performer not satisfied with the organization. And second, the relationship between the correlation low performer and high performer. Separately, we can see this is the uh, relationship between the two variables. Through scatter diagram, we can understand x and y, and job performance. It is the job performance dependent this low job performer and employee turnover and job satisfaction. So for low job performer, employee turnover is minus point. It means this is like this. Okay. For high performer, the job satisfaction, its value very less. It means for this, it is like this. So it's a line, a straight line, है ना? This line, this. It is less sharp. It is its value very high, minus 0.864, and here the value minus 0.161. This for high job performer, and for low job performer means employee turnover more in low job performer. Okay, now we see the next table. So this table, the model, we can see here the R square. Okay, R square means, so this is the R value 0.8, and when we square of this is 0.746. It means R square for low job performers. For low job performers, 74.6%. And for high performer, for R square for high performer, what is the value of R square? Only 0.026. If we convert it into point, this 0.26, which is not significantly. Whether this R square significant or not, we see through this table, ANOVA table. This ANOVA table telling us this is not significant, because p value greater than 0.05. This is not significant, and here its value less than, for low performer it is significant, because p value less than 0.05. What is the p value here? 0.027. Okay, so so we find here there is a the significant difference for low job performer and high job performer. Now we see the coefficient table. In this coefficient table, for low job performers, so what is the p value? It is this. And what is the equation for low job performer? 118.404 and minus 1.50 into job satisfaction. Job satisfaction. ठीक. And it is significant. Significant because p value less than 0.05. For the case for high performer, y equal to 46.174 minus 0.124 into job satisfaction. Okay. And p value, it is greater than 0.05. It is not significant. So moderating effect is telling the low job performers quit job, leave their jobs. Okay, so here we can see the p value. Through p value, we can say the low job performer leave the job, not the high job performer. When we do not split the file, we find there is a negative relationship between the two. Means the job satisfaction influenced by the employee turnover influenced by the independent variable, but not significantly contribute when we take all the 12 cases. But when we split the case and we check the relationship between the job satisfaction and employee turnover for low performers and job performance of high job performers, means job satisfaction and employee turnover, there is a significant difference. Means when we take combine all the 12 observation, when we find there is no significant impact. When we divide this sample 6 and 6, 6 means low performer and high performer, so we find not significant for high performer and significant for low performer. Okay, now question is, that is it is clear, but SPSS uh, doesn't tell us whether this difference, this regression coefficient significantly different or not. So here the significant difference is this we will compare the significant slope. Basically it is a slope. So we will check whether this slope, the first slope is value for low job performance 1.54 and another slope minus 0.124. So we want to check whether this slope is significantly different or not. So directly through SPSS we cannot calculate. Okay, so here we will use free online slope calculator. How to do? So, but before analyzing, we need the 4 values. We will put the 4 values. 4 values means first value, the sample size of low job performer. Sample size is this, and another slope. Okay, slope, that is slope for low job performer. These are the 3 values of low performer. And what is the value? Minus 1.540, and third value standard error. So we will use these value to check whether this slope is significantly different or not. What is the standard error? 0.449. Same as for high performer. High performer, we will take the 3 values. One sample size is 6. To slope, what is the value of slope? Minus 0.124. And third, the standard error value 0.379. So we will put all the 6 values in the online computer and online computer will give us the p value. If p value less than 0.05, we can say the low job performance, leave job, employee turnover high. Okay, so here I am using the calculator, online calculator. So I am stop sharing it. I am opening my internet, stop sharing, and using internet. So I think you can see this. Uh, I am using the internet. I am sharing the Google. This is okay. I think you can see. So free significance of the difference between two slopes. I think you can see it. Okay. We are using online calculator. So here, so you can see significance of the difference between two slope calculator. So you can write it for future use. Significance of the difference between two slope, and then so here we can see this. Okay. So there are six values. So our sample size, what is the sample size? Our sample size is 6. So I am writing here 6. And slope, what was the slope? The slope is minus 1.54, and standard error, it is 0.449, and then sample size for another group 6. Okay, and the slope, it is minus 0.124, and the value of standard error 0.379. Okay, I just press the calculate and we will get the values. Now the t value, what is the t value? It is 2.409. Okay, and the p value is 0.0425. It means it is less than 0.05. So here we can say the interaction term is working. It is a moderation is working here. Now I am stop sharing this. So the my so my next okay, this is about the interaction. Now I am taking the another case study for continuous data when all the three variables are continuous. So here this is my case study. Okay, I think you can see it. Is it visible? Okay, so you can see this case study. Now second, the type that is continuous. Here the so I'm using my PPT to explain this. Okay, this is you can see this continuous moderator. Okay. Hello, can you see it? Okay. So can you see it, this, please? No. Okay, okay, okay. No, you cannot see it. Yes, yes. I'm just showing this employee turnover. Is it visible now? Please inform me. Okay, okay. Thank you, thank you, thank you. Now, I'm taking another case study for continuous moderator. So now I have discussed two cases. The one is it's a third type. So, I have discussed two. One, the predictor variable, categorical predictor variables. So in this case, again, I am just recapitalize. Uh, there are two variable y and x, and another variable, third variable, this. So this is dv, means continuous. It is categorical. When both the variables categorical, then we should use factorial ANOVA. Okay. So in this case study, we found there was no interaction term. Second case, I used the two variables y and x, and then this is moderator variable, and this. Okay. It means it is categorical and continuous and continuous. Now third case, the this moderator x and y. Okay, all the three variables continuous. This is moderator, continuous, and continuous, all the three variables. Okay, now I am taking this continuous variable. So here it's a Beck's cognitive theory of depression. So here we can see the y equal to b0 plus b1x plus b2m, and the third is interaction term. Interaction means moderation. So simultaneously we can use either interaction and moderation. They both same. So in this case study, Beck cognitive theory of depression. This theory suggests depression depends on stress. And another variable, negative cognition, can change the relationship between the depression and stress. Okay. So the depression, it is a continuous variable, stress independent variable, continuous variable, negative cognition, moderator variable, it is continuous variable. So all the three variables continuous variables. Now first of all, we will perform simple regression analysis. Means we want to find the relationship between depression and stress, and then we will find the relationship between depression and negative cognition, and third, we will find the relationship between stress and negative cognitive, and fourth relationship, we will add interaction term also, this interaction term. Okay, so we will use all the three variables, and all the three variables continuous. Okay, So I am showing you the case study of this. So what is the case study? Get continuous, my file continuous mode. Yes, this is okay. This is my uh, case study. So depression, stress, cognitive, negative cognition. Okay, I'm just coming. Wait 1 minute only. I'm just coming. Okay. Now I start this case study. So here, first of all, we use simple regression analysis. We want to find the relationship between this dependent variable and independent variable, and then dependent variable and moderator variable. So I started analyze, then regression, linear, and after it depression, that is dependent variable. So I am transferring here in this box dependent, and stress, that is the independent variable. Okay, so this, and then we tick OK. Now we can see the output. Now output is, this is output. Now you can see the output. So what is the relationship here? The relationship between the stress and depression, it is significant relationship. It means and there is a positive correlation also. You can see the sign 0.4546. Okay, so there is a positive correlation between the two, depression and stress. It means the higher the stress, this is the graph, through graph you can see this is x and this one y, and stress, it is independent variable, and depression, this is dependent variable. It means when your stress level increase, then depression level also increase. So there is a positive correlation between the two variables, and this is regression coefficient, or we can show this bivariate regression equation, y equal to 2.493 plus 0.603 into stress. So through regression coefficient, its sign is positive. It means there is a positive correlation between the dependent and independent variables, and it is significant also because p value 0.05. Okay, now we check the relationship between stress, depression and another variable, that is the another variable, that is moderator stress and relationship, stress and cognitive, negative cognitive. Okay, so I'm sharing my table. So SPSS sheet, you can see there. Okay, so now we check the relationship between y and m. Both are continuous, so naturally we will use simple regression analysis. Analyze, and then the regression and linear. Okay, linear. Analyze, regression and linear. Okay. Now this was the depression dependent variable, depression dependent variable, and negative cognition, that is independent variables. Okay, and then okay, so what is the relationship between? So we can see the difference. I am showing you the output. So output is this, and you can see. Okay, so here what is the relationship? It is a significant relationship because p value less than 0.05. And what is our equation? Y equal to minus 0.307 plus 0.836 into cognitive. And what is the p-value? P-value less than 0.05. It means significant. And what is the relationship? It is a positive relationship. Positive relationship means the as your negative cognition increase, negativity increase, your depression level also increase. Okay, because there is a positive correlation between. This is the sign. Positive sign tell us the relationship between the dependent and independent variable positive. Okay, so it is positive and as well as significant. Now we can see through the graph also, and value of correlations. So I'm using correlation and as well as graph. So through graph and correlation we can also check. So I'm using graphs. So through graphs, I'm preparing the graphs, chart builders, and then OK. And after OK, uh, I think you cannot see it due to some problem. I already told you. I'm showing you the direct graph. So here the simple graph, the depression, that is dependent variable, and stress, that is independent variable. And then continue again. I am preparing the graph for stress, depend this negative cognition and depression. Now I am showing you the graph, so you can see the graph. This is my graph. Now this is the graph. Okay, so this graph, depression and stress. So I double click and I want to draw the regression line, elements, and then fit line at total. Okay, fit line at total. So we can see positive correlation. I already told you there is a positive correlation between the stress and depression. As stress increase, depression increase. Less stress, less depression. Second, the this is the relationship between the stress and cognitive. Negativity के बीच में we will find the relationship. What is the relationship? Again, it is positive. As negative cognition increase, your depression level increase. Okay, now my file. This is my file. Okay, so through correlation, again we can find all the three variables are positively correlated. So we can check, analyze, correlate, bivariate. Okay, this is analyze, correlate, and bivariate, and then we transfer all the three variables here, and we want to see the Pearson correlation table, and then okay, and after okay, I'm showing you the output, so we can see the output. Here we can see all the three variables, all the three variables, there is a positive correlation. Means depression with stress, there is a positive correlation 0.4546, and depression and negative cognition, again there is a positive correlation 0.794. Okay, and all the correlations significant. You can see the stars. Okay, so there is a significant difference. Now we I'm stop sharing this and analyzing the I'm using my file this. So we have seen the now what is the relationship between y and x. There is a positive correlation and significant also. So the relationship between y and m, again it is positively correlated and significant. We have checked it. Now we will use multiple regression analysis. One is the analyze third equation, multiple regression equation, analyze, regression, and linear. Okay, so here I am using two equations. The depression dependent variable and stress and cognitive is this, and then okay, this is my result. Now this we can see the output. This is output, you can see. Okay, now output, when we include both the variables, now it changed the relationship. You can see when I include stress and cognitive simultaneously, the relationship changed. So what is the regression equation? My regression equation minus 0.594 plus 0.156, and what is the variable? Stress, plus 0.740, and variable name cognitive. So here we can see the stress with the presence of this cognitive uh, variable, moderator variable, it becomes non-significant. ये जो है no, because its p value 0.0 greater than, means not significant. It is not significant, and it is this cognitive, it is working because its value, this moderator value less than 0.05. It means with the presence of this, it changed the relationship between the stress and depression. So it is working because its value, you can see 0.136 greater than 0.05. Okay, now we will check the interaction term, whether this interaction term significant or not. So we will check it through the interaction term. So I am using my file, this file, this is okay. Now we will create the interaction term. Next term, there is interaction term. Interaction term, here the interaction term, how to create interaction term? Transform, compute variable, and target variable. So here I am writing the new variable name, that is interaction. Copy and type and label and paste and continue. So the interaction between stress and cognitive, this, okay, and then okay, and after okay we can see here. So this I am showing you the slide, my continuous moderator, this, okay. I think you can see it, this slide, interaction term. So I am again sharing you, if you cannot see it, this is okay, this is my file. I have created another variable interaction, okay. So interaction, now I will use again multiple regression analysis to find the impact of regression, interaction, okay. So analyze, and then after analyzing, regression and linear, okay, regression and linear, analyze, regression, linear, and reset all. So depression, stress, independent variable, cognitive, independent variable, and interaction, independent variables, and then okay. After okay we can see the impact. Now the I am sharing the output. So output you can see here, this is output, okay. Now the NO table tell us it's a significant difference. So whether interaction is significant or not, we can check here. It is the stress significantly related with depression, but negative cognition not significant related with depression. But interaction term is difference, means moderator is working because its value less than 0.05. So we can see here y equal to 9.56 minus 1.45, and x means stress plus, sorry, minus 0.554 into cognitive, and plus 0.197 into interaction. So here the stress, its value less than 0.05, significant. Cognitive, its value less than, sorry, greater than, it is greater than, so it is greater than, so the value, it is great, its value greater than 0.05, and the interaction, its value again less than 0.05. So this interaction tell us whether this it is significantly contributing or not. So here we can say it's a interaction effect. We can see interaction effect. Okay. Now I'm taking another case study where we will see the no interaction. There is no interaction effect. So I am taking another case study to explain the no interaction, how to find the no interaction. Continuous I am stop sharing this and sharing the slide. Continuous, the continuous moderator to group moderator continuous. This is continuous moderator. Okay, so you can see the continuous moderator. Interaction effect, basically interpretation. How do we interpret interaction effect? If interaction is low, okay, means if it is not significant, then we can say there is no impact of the moderator variable. Or if interaction effect is working, if its value less than 0.05, it means uh, there is significant impact of interaction. Okay, same as we have used in the categorical moderator. So the low performer and high performer, so the interaction term, the p value was less than 0.05. So in that case we can say the interaction was working because the p value different for low performer and high performer. Okay, then how to report it and this, so you can go through the book, the Barbara and Warner M Rebecca book. So Warner M, the title name of this book, Applied Statistics. It's a Sage publication book, and Warner Rebecca M. Warner. That is the author name. So if anyone need any book like mediation and moderation, written by the Andrew Hayes, so I have book. So you can take these books. Okay. Now this is this another case study. Here there are three variables. So one is self-study, exam performance, and intelligence quotient. Okay. So the in this case study, self-study and another variable, dependent variable, exam performance, IQ. So this okay, I will provide the book. It will dear participants, you can not my I am sharing my slide just so. Okay, so dear participants, you can note down my number. So this, okay, this is my WhatsApp number and mobile number, same. And this is my email ID, kaushal.sk1971@gmail.com. So I have book of discovering of statistics through SPSS, written by Andy Field. It's a Sage publication book. It's a very wonderful book. You should go through this book. And second is Rebecca M. Warner. It's a Applied Statistics. The title name of this, it's again Sage publication book. And third book written by Andrew Hayes, the Mediation and Moderation. Okay, it is a full, it's a complete book of mediation and moderation, and then you can learn how to report our data. So reporting of data, the Rebecca M. Warner, they also beautifully explained how to report our result or in, okay. So you can go through these books. You can send me your email ID on my WhatsApp number, so I can send you the ebooks, all the three books. Okay, discovering of statistics, and second Rebecca M. Warner, and third book yeah, Andrew Hees, written by Andrew Hees. So you can note down and you can send me email. Okay. So now I am using the third case study, the case study continuous moderator. Here there is no moderation impact. Okay. Uh, did you see slide? Okay. Okay, you could not see the slide. Okay, okay. I am showing again. So I think you could not see the slide. Okay, okay, okay. You could not see the slide. Sorry, sorry. I'm again sharing. Okay, okay. No problem. I'm again sharing this my this. Can you see it? Please inform me. Can you see the slide? Okay, okay. Thank you, thank you, thank you. So please note down. Okay, okay. Thank you, thank you. So you can note down the. You can note. Sorry. You can note down my number. This is my number 94153232 and 9415323233 and the email ID kaushal kaushal dot sk 1971 at the rate gmail.com. Okay, so you can note down. So it's my WhatsApp and mobile number, it's same. And this is my email ID. So you can write me, you can send me your email ID, and I will send you the all the three books. Okay, soft copy. These are very good books. Okay. Now I am sharing the another case study where there is no interaction effect. So continuous moderator and share. So in this case study, you can see the three variables. One is one moderator variable, and this is moderator variable, y dependent variable, and x independent variable. So the self study, it is moderator variable. Exam performance, it is exam performance dependent variable, and IQ level means it is independent variables. So there are three variables. Now we can uh, see our data. So it's a data of 20 respondents data, and this data we can understand it. So in this data, we want to know whether exam performance depend on the there are this exam performance, and X is IQ level. So in this case study, I'm explaining it. This is my dependent variable y dependent variable, and the y dependent variable means exam exam performance exam performance depend on IQ, intelligence quotient. Okay, we know that there is a positive correlation. The higher the IQ, higher may be exam performance. And another variable m, that is self study. Self study may influence the relationship between the y and x. It means if your IQ level is high, there may be possibility that your performance good. But another variable also moderate this relationship. If you uh, devote more time in self study, then your performance may be good. If you are highly your IQ level is high, but you do not devote time in study, then your exam performance will be low. So this independent variable alone, IQ, we cannot say a person who has a high IQ level always give the good performance. If someone has low or low IQ level, but he devote more time in self study, then his performance may be good. Okay, so this is the moderator variable. Now the question, sometimes when units are not same, okay, so we should standardize our data. Standardization, we should, because the unit of this self study different from the performance and IQ level. So it is better to standardize our data. How to standardize our data we can see here. Now, so here the I am converting this data into standardization. So analyze, and then descriptive and descriptives. Okay, analyze, descriptives and descriptives. Now simultaneously I am selecting all the three variables and transferring here variable box. Okay, so and then tick save standardized value as a variable. So I have standardized all the three variables, and then okay. So this is okay, and after okay we can see this. These are the standardized three variables, new variables. Okay, I think you can see it, all the three variables. Now we use the simple regression analysis, means the relationship between the two variable. One is exam performance and another is IQ. Okay, so I am using two variables, analyze, regression and linear. Okay, analyze, regression, linear, and I want to check the relationship between exam performance and IQ level. Is it any relationship between the two variable or not? So exam performance and intelligence. So actually the standardization. So if we should do standardization if our questions not in the same nature, means so I am showing this. Okay, so the your question is how to know the standardization of which variant is required. Okay, so basically we standardized our questions when the units of the questions are different, then we should standardize our questions or variables. If we are taking all the questions in a means 0 to 100, then there is no need to standardize the questions. So like you can understand, for example, I am taking 10 statements, means question number 1, 2, 3, and all the questions in the form of 0 to 11 or 0 to 100. Okay, if all the questions in this form, then there is no need of standardization. Okay, but if my the one scale is in different form and another is different, that means in the three questions I am taking 1 to 10, and rest of the three question 4, 5, 6 I am taking 0 to 100. So then in this case we should standardize our questions. Here 10 means low value, and here 10 means high value. That is why we should, if our units means options are different, then we should standardize. If we are taking all the 6 question in 0 to 10 or 0 to 100, then there is no need to standardize the questions. Okay. So how did we compute Z score? Okay, I'm again repeating. Okay. So your question is, how did we compute Z score? So I will repeat again. So for, if you want to convert your variables into standardized variables, then go to analyze and descriptive statistics and descriptives. You can write anywhere. So analyze, descriptive statistics and descriptives, and simultaneously we will select all the three variables and transfer here. Okay, and then tick save standardized values as a variable. You can see here, save standardized value as a variable, and then okay. When we do okay, we will get the standardized variable. These are the standardized variables. Okay, all the three variables. Now I am using the simple regression analysis to check the relationship between the two variables. So analyze, regression and linear, and then okay. So exam performance depend on IQ. So exam performance dependent variable and IQ independent variable, and then okay. So this is my result. So I'm showing you the result. So result is this. Now you can see. Okay. So in this table, the coefficient table, we can see here the relationship between the two variables. Two variables means this yeah, it is negatively related. Okay, because p, sorry, not negatively related, less than 0.05. It's less than 0.05. Y and X. Y is exam performance and X means IQ. It means the IQ significantly contribute to the exam performance. Means if your IQ level high, your exam performance will be high. Okay. Now second relationship I find, I check the second relationship, means the IQ over exam performance and self-study. Okay, so is it any relation between the two or not? So we can see here the analyze, regression, linear. So now I am taking two variable. Exam performance depend on self-study. More you do self-study, your performance would be better. And then okay. Now okay, we can see here the output. I'm showing you the output. The output is this. So what is the output? Output, the what is the p-value? Here p-value means y and x, and p value less than 0.05. X means it's not x, it's basically moderator. Okay, self study, and this is exam performance. It means this self study also significantly contribute to the employee performance. Now we take simultaneously both self study and uh, self study and IQ. So I am stop sharing this and showing you the uh, continuous moderator and then this. Okay. Now I am using simple I am using here multiple regression analysis, the dependent variable and two independent variable, analyze, regression and linear. Okay, and then the exam performance dependent variable, IQ independent variable, self study independent variable, and then continue. Now we check the relationship. Now the stop sharing it and sharing the output. This is output, you can see. Okay, now what is the output? So in the presence of self study, IQ become insignificant. Here y, that is exam performance, and the variable, the IQ, and plus another variable self study. So now with the presence of the self study, IQ, the relationship between the IQ and exam performance insignificant, means not significant related. Now the self study and uh, exam performance, it is significant. It means significant more impact, more important than IQ level when we take simultaneously both the variables, because it is significantly related. If we devote more time, then exam performance would be better. Okay, so it changed the relationship. With the presence of this, it is changing whether this interaction term is significant or not. So we will add interaction term and then check the impact of interaction term. Okay, now I'm creating the new variable of interaction term. This is my table. The constant, so we do not consider the constant. So your question is constant value. So basically constant value, here we are checking only the here we are checking the value of the regression coefficient. We are not taking consideration the constant. There is no meaning of constant here. So the main purpose to check the significant relationship of the regression coefficient, means B1, B2, B3. So here we are not taking the constant. We are not taking constant value. Okay. So if you want to write, okay. So if you want to write the constant value, so you can, or you can apply the multiple regression analysis with original variable. So do not use, don't convert your variables. So if you want to write the model, then you should use the uh, unstandardized variables. You do not convert variable. Okay, for interpretation purpose we can use our original variables, so we can write the equations. Now this my first questions. So I'm stop sharing this, and my this is okay. Now I am creating the new variable, that is interaction term. Okay, interaction term, then transform compute variable, then I am writing here interaction, interaction. So interaction, copy and paste. Okay, interaction of self study and IQ, independent variable. Okay, and then okay, and after okay, again we will use the multiple regression analysis. Okay, so now you can see the interaction term here. This is interaction, another variable interaction. Okay, now I am adding another term, interaction term, analyze. I'm using again multiple regression analysis, analyze, regression, and linear. Okay, then exam performance, dependent variable, IQ, independent variable, self study, independent variable, interaction, independent variable. Okay, and then continue. After continue, we can see the output. So I am showing you the output. The output is, this is my output. Okay, now you can see the output. So here we can see there is interaction is not significantly contributing to this model, because the interaction term, that is uh, its value greater than 0.05. So here we can see the y equal to constant. This is the regression coefficient, and b1 value 0.5259. It is IQ, and plus the 0.719 into self study, and plus, sorry, minus 0.004, very less regression coefficient, almost zero, and it is interaction. So it is not significant. It's not significant because its value greater than 0.05. It is not significant. Okay, so for reporting purpose, so your question how to report the constant. So for reporting purpose, we should use the our original equations, like and again showing you the my data. This is, so we can take the interaction of this. So here the new variable we can create, the compute variable, and interaction int. Okay, so int, the self study and exam performance, and then okay, and after okay we can see the continuous moderator. So the next, okay, so I'm performing with unstandardized score, same case study, analyze, regression, linear, and then the exam performance, I, IQ, self study, and interaction. Okay, and then okay. So but our results different. Here we can see the results are different. This now you can see the results are different. So here interaction term is significant, but when we do not standardize our score, then the results are different. So I think when our variables are not standardized, means the scale, different scale, then we should convert the standard form. Now, how to report it? Your question is how to report the. So you can go through the book, the Rebecca M. Warner. I already told you it is a very beautiful book. How to report our results of interaction and other independent and dependent variables. So you can go through the book, go through this book, Rebecca M. Warner. So you can write me. I will send you the copy of this book. Okay. Now this is about the interaction. Now how to use the process macro. So process macro, it's a software. So in this process macro, it's very simple software. So we just put the value in a process macro and we will get the interaction effect. Okay. So but before using process macro, we should learn the mediation and moderation in a through spaces also, because unless we understand the concept of mediation and moderation, so we should not use directly process macro. So first of all, we should learn in spaces also, and then we should use process macro also. So about the process macro, so I am using the how to download. So basically process macro, you can see here, you can download the process macro, process macro. Can you see this Google? Please inform me through chat box. Can you see the Google? Okay. So how to how to download the process macro? So it's a the process macro. This is the site, the process macro, and then we go for here the download. Okay, download. You go to download and download. You can see here download process 3.5. Okay, you just click it. After click download the, you will get the zip folder, zip in a zip form folder, and you unzip it, and after that you will get the one file, the name that is .spd file. Okay, so you just download this and you come to SPSS. I'm stop sharing this and opening my SPSS. So you will come the SPSS. So you download the zip file and put on a desktop and unzip the file, and then you open your SPSS. You go to the utilities, and utilities, the custom dialog, and install custom dialog. Okay, so you will open your SPSS, go to utilities, custom dialogs, install custom dialogs, and then you will find, you are looking here .spd. Okay, because I have already downloaded and install this. So you will select your SPD file. I told you, you put the folder on a desktop, and through desktop you can open the SPD file. Okay, and then your file will show here, and then you click the open, and then your process macro will install, and then you can check the process macro like analyze, regression, and process. Okay, this is the process macro. This is process macro, and you just click here and review this. You will get the process macro. So this case study, same case study I am using here in a process macro. Okay. So depression, that is dependent variable. Here we do not need to convert or create the new variable like here interaction term. We do not need. So I am deleting it because there is no need of this particular variable. Okay. So I am using the continuous variable, this analyze process macro. I am using process macro and process 3.3. Okay, and then this. So depression, it is dependent variable. Stress, it is independent variable. I am putting here X variable, and cognitive, it is.
Excuse me, sir. Sir,
Yes.
sorry to intervene. Sir, your
Yes.
screen is not visible.
Okay. Oh, sorry.
Yeah.
Oh, yes, I could not stop the.
No problem.
Yes. I'm just taking it. Okay. Continuous moderation. Okay. Can you see now?
Yes, sir.
Okay. Thank you.
Thank you, sir.
Okay. Now you can see it. Now I am performing this same problem in a process macro. So how to perform it? Now you can see it's very easy. Analyze, regression, and process. Okay, process. Analyze, regression, process, and then tick. And after it, so you can see three variable. Depression, it is dependent variable. Y. So I am transferring here. X, stress, independent variable. I am transferring here. And cognitive, that is moderator. So moderator variable I am transferring here. Moderate variable W. Okay, moderator variable W. So this is okay. So there are large number of models. 1, 2, 3, 4, more than 100. So but my model is model number 1, because Andrew, he is written the book on the process macro. And when you download this process macro, you will get the template, and in a template there are large number of models, means model number 1, model number 2, model number 3, very complex model you can see. So I am using very simple model. So here depression, independent variable, stress, independent variable, and moderator variable, this in the moderator variable W, this is cognitive. Okay, and then I'm clicking about, nothing to do here, opens, I do not need anything, and then multi-categorical, so I do not need, because I am not using categorical variable here. All the three variables are continuous. So continue, and after continue, okay. So I am showing you the output. Stop sharing and the output. So you can see the output. This is output. Can you see this output? Please inform me through chat. Can you see the output?
Yes, sir, we can see the output.
Okay, okay. Thank you, thank you. Now I am interpreting the output. You just uh, okay, okay. Now this is the output. So it is very easy to perform moderation in a process macro. Okay. Now there are the model number one, the y, that is dependent variable, x independent variable, and w here moderator variable. So moderator variable means depression. I have taken three variable in this case study. One, the variable depression, stress, and another variable, the depression, stress, and negative cognition. Okay. So I am showing you the output. So output, where is output? Output. This is output. Okay. Now you can see the output. So here output, the first table, the model summary, it is about the model summary. It's a R variable. R means multiple R, its value 0.80, and when we square it, it is R square coefficient of determination, its value 0.65, and theoretically R square value should be greater than 0.6. Okay, so it is desirable because it is above the cutoff value. It is 65.06%, and here we can see this regression coefficient, it is significantly contributing because p value less than 0.05. Now the model 1, in a model 1, this is the coefficient value. This is coefficient 9.560, regression coefficient. It's a intercept or B0. We can say it is B0. And this B0, this is the B0. Okay. Now I can write my model y equal to 9.5602 minus 1.450 minus into x. X means independent variable. So we should write our model this way and report like this: 0.5536 into m. M is moderator, and plus 0.1966 into interaction. So I am writing here interaction. So this is my final model. We should report this model in our research paper or thesis. Okay, and interpret the these terms, means x means the stress. Okay, and y means depression, moderator means negative cognition. Okay, so we will write this term. So here we can see the x, it is significant. This is not significant, this one, but interaction term, it is significant because its p value less than 0.05. Earlier we told you the p value should be less than 0.05 for checking the significant impact. Now the R square, in the next table, the interaction term means multiplication of x and w. W means moderator. So due to this, what is our R square? R square change is this: 0.07 means 7.63%. Whether this change, R square change significant or not? Who will tell us? This P value. And here the P value, it is less than 0.05. Okay. Now we see the next table. Here conditional effect of the focal predictor at various at value of the moderator. Okay. Now we can see here as the cognitive impact. We want to check the impact of cognitive. Now the value of this, there are three conditions. When the value of moderator variable 6.2, so it is not significant. When the value increases, it is 8, then it is not significant. And for higher value, it is significant. It is giving the less than 0.05 value. It means for highly negative cognition, depression level increase. And after this, I am clearing all this. Okay. So this is about the process macro. It is very simple to use process macro. And the another case study of the categorical data and continuous independent variable and continuous dependent variable, means second case study I will perform tomorrow uh, in a process macro. So today I explained a process macro only one case study, that is when all the three variables are continuous. So tomorrow I will take it this case study, and as well as the mediation. I will use mediation with SPSS and as well as with the process macro also. So tomorrow I will do this. Any query? Your question, thank you so much. Today's session was very tough. Okay. So any question related to this? Okay, thank you, dear participants. So tomorrow we will start the mediation, and one problem of moderation we will continue. Okay, thank you very much, madam. Conditional interaction means when we take the different value of the moderator variable. This is the conditional interaction. If I am taking the value of 0 to 100, so one condition I am taking 10, another condition I am taking value of 20, and another third condition the uh, value is 30. So for each value we check the impact of the impact on depression level. Here the negative, so I have taken the three values 6, 8 and 8. So it means when we increase the value of the negative cognition, then there would be high depression. When there is low negative cognition, we found there was no significant difference. We found there was no significant difference.
Good morning, sir.
Good morning. Good morning, sir.
Sorry. Good evening, sir.
Good evening, sir.
Is today's session over, sir?
Yes, yes, yes.
Okay. Thank you very much, sir.
Okay. Thank you, sir.
Thank you.
Thank you, sir. Thank you.